So in this very, very brief lecture, we're going to be talking about how to graph inequalities on a number line. Obviously, when we're talking about inequalities and we have an infinite number of solutions oftentimes, we're not going to be able to list them all. So we're going to have to present them graphically a lot of the time. And this is going to change when we have when we have inequalities in two variables, which we'll do later on in the course. But for now, this will just be graphing inequalities on a number line. So we've got three inequalities there and number lines for each. And the first thing we're dealing with when you are graphing an inequality is to deal with the endpoint. Where's the endpoint? Where's it start, right? And obviously we're going to do this one first here. This x is greater than 6. And um, so the first thing you have to establish is the endpoint, right? We're going to be making, in geometry, we'd call it a ray, but we're essentially going to be drawing an arrow. And it's going to be, the arrow that we're drawing is going to be going over the solution region. Then we're going to go over all the values of x that would make a true statement. So when we are dealing with this, there are certain details that you have to pay attention to properly communicate the correct inequality. In this case, we've got a x is greater than, not greater than or equal to. If the inequality symbol is less than or greater than, we're going to put an open circle on in this case, on the 6. If it's less than or equal to or greater than or equal to, we're going to put a closed circle or a dot. Right? So the first thing we're going to do is we're going to say, okay, well, I've got a greater than with no equal sign underneath it. So I'm going to take the 6. I'm going to put an open circle. I'm not going to fill it in. Wow, that's a little messy. That's okay. Right? What that tells us is 6 is not a solution. It's not a solution to that. 6 is not greater than 6. If it's open, it's just kind of, think of it as kind of the edge of the solution region. Don't try to say, okay, x is greater than 6. What some people do is they mistakenly circle 7 because 7 is greater than 6. Well, if you circle 7, you're missing values that are greater than 6 by doing that. Like 6.5 is greater than 6, but it's not going to be counted. So always circle, whether it's an open circle or a closed dot, always circle the value that's in the inequality. So in this case, we've got an open circle and it's on 6. And then we have to just ask ourselves, we need to draw an arrow from that circle that goes over all the values of x that make that a true statement. So we're going to draw that arrow over the solutions to indicate everything that this arrow goes over will make that a true statement. And here's the little hint, right? When we have the variable on the left-hand side like we do, the inequality symbol is pointing in the direction of the arrow. And here's what I mean by that. This one here, this greater than symbol, is pointing to the right. If you were to view this over here as an arrowhead, it would be going this direction. Right? So, and this is a pretty easy one to see that, okay, well, what values of x are greater than 6? 7, 8, 9, 10, and so on and so forth. It just keeps going forever and ever. That's what an arrow means in math. It's going to go forever and ever. So rather than write out, we want to be able to do this graphically as well. We want to be able to communicate this graphically as well. And it's just that straightforward, really. X is less than or equal to 9. All right, so if it's less than or equal to, I look at the endpoint. I know I'm going to be doing something at 9, at the 9 part on the number line. And since it's less than or equal to, I'm going to put a closed dot. All right, I'm going to put a closed dot. That means 9 is a solution. Because if I plug 9 in for x, that's a true statement. 9 is less than or equal to 9. And then I'm going to look at this and say, well, what values are less than or equal to 9? I got the equal to part because it's a filled in dot. And then I'm going to go this way forever and ever and ever, right? And 8, 7, 6, 5, 4, da, 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 are all going to be less than 9. But we can't possibly list them all, right? So we're going to show them graphically. Right? Now, it's nice when we can be able to give you a pre-printed number line and such like we do in these first two, but sometimes it's not an option. Sometimes it's not, or sometimes you have to do it by hand. Take this one, x is less than 72. I do not want you to put 72 little tick marks on a number line. That's ridiculous. All you need are the number and 0 in the correct position. That's all that really matters here. So in this case, you can get away with saying, all right, x is less than 72. I don't want 72 marks here. That's obnoxious. Right? I'm going to put 0 here and 72 somewhere to the right of it. It doesn't matter where. It doesn't matter where. I don't care where it is, as long as you put the positive number to the right of the 0. If it were negative, you would switch these positions. Right? And then we just follow the steps as indicated. All right. So it's an open. It's a less than symbol. So it's an open circle here, and then it's less than 72. So I'm going to go like that. And that is how I graph that one. I don't need every little mark here. If I give you one that has the numbers on it, that kind of gives you a hint that says, probably my solution should have these. If they don't, maybe go back and check. But if it's a number that's kind of too big to reasonably do on a number line, make your own and just make sure that the 0 and the number are in the correct position. So that's about all for graphing inequalities on a number line. We're going to expand on this when we start talking about compound inequalities, but that's about it. We're going to get some practice on this in class. I hope this helped.